Welcome to the session on projectiles, projection at any angle. The objectives for this session are to solve problems involving particles which are projected at any angle. Problems involving particles projected at an angle can be solved by resolving the initial velocity into horizontal and vertical components. So, taking a look at this diagram here, we have the x-axis here denoting the range, and this is the distance from the point from which the particle was projected to the point where it strikes the horizontal plane. The time of flight of the particle is the time taken for the particle to move from its point of projection to the point where it strikes the horizontal plane. The greatest height of the projectile is reached when the vertical component of its velocity is equal to 0. Let's now take a look at an example. A particle is projected from a point on a horizontal surface with initial speed 150 meters per second at an angle 10 degrees above the horizontal. After projection, the particle travels under gravity until it strikes the surface at a point A, as shown in the diagram. So here's 150 meters per second at an angle of 10 degrees. We are required to find the time the particle takes to reach its highest point above the ground, and to find the time the particle takes to reach A, and also to find the range of the particle. So let's solve this. We're going to have a go at part A first, and find the time the particle takes to reach its highest point above the ground. Notice that the initial velocity, vertical component, is 150 sine 10 degrees, as shown in the diagram. So, resolving the velocity of projection vertically, we have uy equals 150 sine 10 degrees. And taking the upward direction as positive, we have uy equals 26.047, which is of course 150 sine 10, vy, the end velocity, or the velocity at the maximum height, equals 0, and ay, the force of gravity, equals minus 9.8, since we're taking the direction upwards as positive. And we're going to try and find the time t. So given these equations of motion on the right-hand side of your screen, we're going to select one of these which uses all these four letters. In particular, the equation we're going to use is v equals u plus at. And so plugging in the values that we have gives us u plugged in as shown, v equals 0 plugged in as shown, the acceleration due to gravity plugged in as shown, and t is our unknown. So we have one equation and one unknown, and we can now manipulate this equation to find the value of t. To give us t equals 2.7 seconds. Now let's take a look at part B. We are required to find the time the particle takes to reach A. So let's solve this. The vertical velocity, as shown, is 150 sine 10. So resolving vertically gives us uy equals 150 sine 10. we're going to take the upward direction as positive. The vertical displacement from the starting point to A is equal to 0. The initial velocity is equal to 26.047. The acceleration is equal to minus 9.8, since we're looking at the vertical direction, and this is the force due to gravity. And we're trying to find the time the particle takes to reach A, so t is unknown. So let's see which formula we're going to use, given that we have S, U, A, and T. So here are our equations of motion, and the formula we're going to use, or the equation we're going to use, is this one, S equals ut plus a half at squared. It contains all of these letters, and we can then find the value of t. So let's plug everything in. S equals 0, U equals 26.047, A equals minus 9.8, therefore a half A equals minus 4.9, and t is unknown. So solving this gives us either t equals 0 or t equals 5.316 seconds. Now we can't have t equals 0 since the particle actually does travel, and therefore t is equal to 5.316 seconds. Now let's take a look at part C. We are required to find the range of the particle. So let's solve this. Notice that the horizontal component of u, or the initial velocity, is 150 cos 10 meters per second. So resolving the velocity of projection horizontally, we have ux equals 150 cos 10. Now horizontally, we have distance equals speed times time, since there is no horizontal acceleration. Therefore, plugging in these values, ux, initial speed, and the time from part B, using the unrounded value, gives us that the distance is equal to 785 meters. Now let's take a look at another example. A ball is thrown from a window with speed 30 meters per second. The window is 20 meters above horizontal ground. The ball hits the ground 3.5 seconds later. So in our diagram, here's 30 meters per second. And the window is 20 meters above horizontal ground. We are required to find the angle of projection of the ball and the horizontal distance from the window to the point where the ball hits the ground. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first, where we're required to find the angle of projection of the ball. Notice that the vertical velocity, or the vertical component of the velocity, is 30 sine alpha, as shown in the diagram. So let's solve this. Resolving vertically, we have uy equals 30 sine alpha. And taking the upward direction as positive, we can specify the values of u, s, a, and t. So we have u equals 30 sine alpha, the displacement s equals minus 20, acceleration due to gravity equals minus 9.8, and time t equals 3.5. That's part of the question. So we have U, S, A and T. So which of these equations of motion will we use? We're going to use the one which encompasses all of these letters. In particular, we're going to use S equals ut plus a half at squared. And plugging in all these values, U goes here, S goes here, A goes here, and T goes here and here. And tidying up and calculating gives us sine alpha equals 0.762. Which implies alpha equals 22.4 degrees. Now let's take a look at part B. We are required to find the horizontal distance from the window to the point where the ball hits the ground. So let's solve this. We have the initial velocity, or the horizontal component of the initial velocity, equals 30 cos alpha. And since we have the value of alpha from part A, we know that ux, once we plug this into our calculator, equals 27.735. Therefore, if we resolve horizontally, we have u equals 27.735. The distance s equals x, this is unknown. The acceleration horizontally is equal to 0, and time t equals 3.5. So we have the letters U, S, A and T. So again, let's select one of these equations, which includes all of these letters. And again, it happens to be this one, S equals ut plus a half at squared. And let's plug everything in again. U goes here, S goes here, S is equal to x, it's unknown. This is what we're trying to find. The acceleration equals 0, and t equals 3.5. Now the last term, as we can see, disappears because acceleration is 0, so we have a 0 multiplier. And therefore, the value of x equals 97 meters to two significant figures. Now let's take a look at another example. A stone is thrown from the top of a building with position vector 20j meters with respect to a fixed origin O. The velocity of projection is 22I plus 17.6j meters per second. The stone moves freely under gravity, passing through point B, which has position vector ki plus 12j meters, where k is a constant, before landing at the point C on the x-axis, as shown in the diagram. The particle takes 4 seconds to move from A to B. Find the value of k, find the time taken for the stone to land at point C, and find the angle the velocity of P makes with the x-axis as it reaches C. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. We will begin by taking a look at the diagram in more detail. Here's our fixed origin O, and notice that the building or the stone is thrown from the top of a building with position vector 20j meters with respect to this fixed origin O. So in the diagram, here's 20 meters. The velocity of projection is 22I plus 17.6j. And here we've got point B, and this has position vector ki plus 12j. and we're required to find the value of k. So let's solve this. Resolving horizontally, we have u subscript x equals 22, the velocity of projection. The horizontal displacement is equal to k. The horizontal acceleration is equal to 0. And the time taken is equal to 4 seconds. So we have U, S, A and T. And again, let's select one of these equations of motion to use, which uses all of these 4 letters. So we're going to use this one, S equals ut plus a half at squared. And plugging everything in gives us S equals k here, U equals 22 here, A equals 0 here, and T equals 4 here and here. Tidying up gives us that k equals 88. Now let's take a look at part B. We are required to find the time taken for the stone to land at point C. So let's solve this. We're going to take the upward direction as positive, and resolving vertically, we have the displacement equals minus 20. The initial velocity, or the vertical component of the initial velocity, is 17.6. The stone is moving freely under gravity, so acceleration equals minus 9.8, since the upward direction is positive. And we're going to try and find the time t. So again, let's see which of the equations of motion we should use out of these. And again, we're going to use this one, S equals ut plus a half at squared. And plugging in all the values, we have S equals minus 20 here, U equals 17.6 here, A equals minus 9.8 here, and T is unknown. So rearranging gives us a quadratic, as you can see. And solving this quadratic gives us t equals 4.499 or t equals minus 0.907, which is clearly impossible, since time t is greater than 0. Therefore, we have that t equals 4.499. And now for part C. We are required to find the angle the velocity of p makes with the x-axis as it reaches C. So let's solve this. Let's resolve horizontally. We're trying to find v, the final velocity. We have that the acceleration horizontally is equal to 0. The initial velocity horizontally equals 22. And now let's decide which of these equations we're going to use. We're going to use v squared equals u squared plus 2as. And even though we have two unknowns, you may be wondering why we've used this one in particular. Another one may have worked just as well, but what we should have hopefully spotted is that the 2as will disappear, so it doesn't make a difference that we don't know what s is. So v goes here, u goes here, and because of the a equals 0, this last term is going to disappear. And therefore, v equals 22 meters per second in the horizontal direction. Now let's resolve vertically. Vertically, the displacement is minus 20. The initial velocity vertically is 17.6. Acceleration due to gravity is minus 9.8. And we're going to try and find the final velocity. So we have u, s, a, and v. And which of these equations are we going to use? We're going to use this one. V squared equals u squared plus 2as. So plugging everything in, u goes here, s goes here, a goes here, and v is unknown. So let's plug everything in. V is unknown, u equals 17.6, a equals minus 9.8, and the displacement s equals minus 20. And plugging this into our calculator, is going to give us v equals minus 26.49075 in the vertical direction. So the final velocity is 22I minus 26.5j. And therefore we can now also find the angle that's made with the x-axis. Here's our x-axis. We've enlarged this a little bit because the diagram is a little bit small. And here's our angle theta. This is 26.5 or minus 26.5. And here's 22. And we can use tan theta equals opposite over adjacent to give 26.5 divided by 22, which then implies that theta equals 50 degrees to two significant figures. This brings us to the end of this session. If you have understood its contents, you should be able to solve problems involving particles which are projected at any angle. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.